Hello viewers, welcome to Auntie IJ's chemistry class. In this channel, I'll be helping you out with problems in chemistry. We are going to look at another aspect of electronic configuration. Recall that we have been treating electronic configuration for some time now. And today we are going to look at electronic configuration of transition elements. Electronic configuration of transition elements. Now, before we go into writing the electronic configuration of transition elements, we ought to know what they are. Transition elements are a group of elements found between group 2 and group 3 of the periodic table. Now, today, the electronic configuration of the transition elements we are going to look at is the electronic configuration for the first transition series. That's the first 10 transition elements. And these transition elements are metals. They are metals. Now we are going to look at how we can remember the names of these first transition elements. The first 10 transition elements. How are you going to remember their names? I use this caption. Scanty van chromalphe konikuzin. I take it again. Scanty van chromalphe konikuzin. Where the first letter is usually written in a capital letter to represent an element. But this is actually not their symbols. For example, scan is not the symbol of scandium anyway. But let's go ahead. If we are writing the electronic configuration of the first transition series or the transition elements, we have to consider or look at or understand the electronic configuration of argon and probably calcium. Okay, I think we should look at the electronic configuration of calcium. Now, if we are to write electronic configuration of calcium, Ca 20. Calcium has the atomic number of 20. If we are to write electronic configuration of calcium 20, we will get 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2 for calcium. Now the electronic configuration, the atomic numbers of these transition elements starts from 21. Scandium has atomic number 21, titanium 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29, and zinc 30. Now let's write the electronic configuration of the first 10 transition elements. Let's say elements, electronic configuration. Permit me to write with in short form. So we have scandium Sc 21. That is scandium, has atomic number 21. Now the electronic configuration will start from 20, which is a calcium. And calcium ends in 4s2. So we say 4s2 and 3d1. Now you may ask me why D. The transition elements fill 3d orbital. Remember the 3d orbital when we talked about the orbitals, sub-energy level, s, p, d, f orbitals. So transition elements are known as 3d elements because they fill 3d orbitals. So we have 4s2, 3d1. 4s2 tells you that we have reached 20. 3d1 tells you this is 21. So let's go to transition element. Let's write the transition element for titanium. Titanium 22. We have 4s2 3d2. And we write for that of vanadium, V, which is 23. We have 4s2 3d3. Then we go for chromium. Chromium, Cr24. And that is 4s2 3d4. But that's not how we write it. I purposely wrote it like this so that I'll be able to explain to you that when we are talking about filling the electrons in the orbitals, we consider certain rules. And one of the rules is that the orbitals must be completely filled to balance. So as a result of that, 3D has 5 suborbitals. And if you fill 4 electrons in them, 1 will be left empty. So because of that, 4s electron is promoted to 3D orbital. I use the word promotion because 3D orbital is higher than 4s. And I believe some people you may be wondering why I was writing 4s before 3D. Because 3D is of a higher energy level. So we correct and write 4s1 3d5. That does it. So let's look at the electronic configuration of manganese. Manganese. Electronic configuration of manganese. Manganese with atomic number 25. So we have 4s2 3d5. And then electronic configuration of iron. Fe is the symbol of iron with atomic number 26. We have 4s2 3d6. Then we go for cobalt. Cobalt with atomic number of 27. So we have 4s2 3d7. We write the electronic configuration of nickel. Ni for the symbol of nickel with atomic number 28. We have 4s2 3d8. Then we write the atomic number electronic configuration of copper with atomic number 29. Now, copper follows the same format that chromium follows too. In copper, we are supposed to write 4s2 3d9, but it will not balance. It means that one of the d orbitals will have only 1 electron and it will not balance. As a result of that, we promote 4s electron to 3d orbital. So we now have 4s1 3d10. That's why it's written. And then we write the electronic configuration of the last element amongst the 10 transition elements. We have zinc, atomic number 30. So we have 4s2 3d10. 4s2 3d10. This is how we write the electronic configuration for the first 10 transition elements. Don't forget to remember these elements using the acronym Scantivan Chrome and Fer Conico Zinc. Thank you for watching. Don't forget to subscribe to this channel so that you get subsequent videos. If you have questions, please drop your questions in the comment section.